In 1354, a French knight named Geoffroy de Charny exhibited a linen cloth in the small village of Lorey. This marks the artifact's first definitive appearance in the historical record. From the moment it was displayed, it generated immediate controversy, with the local bishop declaring it a contemporary forgery. The artifact is a large linen fabric woven in a 3:1 herringbone twill pattern, measuring 4.4 meters long by 1.1 meters wide. The cloth possesses a highly unusual optical property. The sepia-toned emoticons on its surface act as a photographic negative. When Italian lawyer Secondo Pia first photographed it in 1898, his negative plates revealed a positive image of a human form. The image encodes precise anatomical details, and the coloration is strictly superficial. The markings are confined to the outermost layer of the fibrils, a depth of roughly 200 nanometers, with no pigment penetrating into the threads. In 1988, scientists attempted to settle the question of its age using accelerator mass spectrometry. 3 independent laboratories tested a sample of the cloth and concluded that the flax was harvested between 1260 and 1390 AD, coinciding with its first documented appearance in France. Over the last 2 decades, however, researchers working in physical polymer chemistry and crystallography have challenged that conclusion. By measuring the mechanical strength and chemical degradation of the linen fibers, these tests produce data that is consistent with an origin 2,000 years ago. This creates a direct impasse in archaeometry. 2 rigorous scientific disciplines, radiocarbon isotopic dating and biophysical material analysis, have produced timelines that are mutually exclusive. To understand the true age of the Shroud of Turin, we have to dissect the statistical integrity of the 1988 radiocarbon data and map it against a technique known as wide-angle X-ray scattering. The 1988 carbon-14 testing operated under a sampling protocol where a single strip was excised from a handled outer corner of the cloth. This strip was then divided and distributed for blind testing. 3 laboratories were selected for the analysis: the University of Oxford, the Swiss Federal Institute of Technology in Zurich, and the University of Arizona. The labs published their findings in the journal Nature in 1989. They reported a consensus, stating with 95% confidence that the material originated in the Middle Ages. That dating stood largely unquestioned until 2019, when a team led by Tristan Casabianca published a reanalysis in the journal Archaeometry. They utilized the original, raw laboratory data obtained from the British Museum. The researchers discovered a discrepancy. The raw measurement values supplied by the laboratories to the British Museum did not match the finalized data ultimately published in the Nature article. This scatterplot displays the individual carbon-14 data points from the 3 laboratories based on that raw data. Rather than clustering together, the measurements exhibit high statistical heterogeneity. The dates from Oxford, Zurich, and Arizona do not align along a common mean. Look at how these confidence intervals diverge. A variance this high suggests that the corner strip exiled in 1988 was physically inhomogeneous. The chemical makeup of the cloth at one end of the sample was different from the cloth at the other. By standard statistical practices, these heterogeneous datasets cannot be combined to calculate a single reliable date range. To find a physical explanation for why the isotopic data varied across such a small piece of fabric, chemist Raymond Rogers initiated a study in 2005. Using Fourier transform infrared spectroscopy, Rogers discovered dyed cotton fibers woven into the threads of the radiocarbon corner. These cotton fibers are not present on the main body of the shroud. He also detected plant gum resins, materials historically utilized to splice threads together. Like the cotton, these resins were absent from the rest of the artifact. This evidence forms the basis of the invisible reweaving hypothesis. It posits that the 1988 sample was taken from an area where 16th century artisans spliced dyed cotton and new linen into the cloth to repair fire damage. Under this model, the 1988 isotopic tests were accurate at measuring the carbon they were given, but they were dating a contaminated, unrepresentative patch rather than the original artifact. Because the Vatican has barred further destructive sampling, recent scientific efforts have pivoted to non-destructive biophysical dating methods. These methods rely on the material science of linen. Woven from flax, linen is primarily composed of long, ordered chains of crystalline cellulose. Over centuries, exposure to ambient temperatures and atmospheric moisture causes these materials to age. The intramolecular hydrogen bonds holding the crystalline cellulose together slowly break down, decreasing the molecular order of the fibers. In 2022, a team of Italian scientists led by Liberato De Caro utilized wide-angle X-ray scattering, or wax, to measure this structural degradation. This diagram illustrates the mechanics of wax. Researchers fire X-rays into a material, which reflect off the internal crystalline lattice planes. A highly ordered crystal structure produces a scatter pattern with sharp, intense peaks. As the cellulose ages and the crystal lattice breaks down, the intensity of those X-ray scatter peaks drops. This creates a direct rule for structural dating. Assuming normal natural aging, less crystalline structure yields lower intensity peaks, which correlates to an older age. De Caro's team published their findings in the journal Heritage, comparing the X-ray scatter profile of a microscopic thread retained from the 1988 shroud sample against linens of known historical ages. The shroud thread did not match the structural profiles of medieval fabrics. Instead, its degradation metrics aligned with a sample designated FII, indicating an age of nearly 2,000 years. Sample FII is a historically verified 1st-century linen fabric excavated from the archaeological site at Masada, Israel. These crystallographic results align with independent physical data, including mechanical tensile strength tests and studies documenting the depletion of vanillin in the main body of the shroud. Structural polymer chemistry provides a peer-reviewed physical argument for an ancient Levantine origin. Despite these findings, the broader archaeometric community has questioned the reliance on structural degradation to date the shroud. A primary challenge is that X-ray scattering for dating textiles is a novel technique. It lacks the decades of calibration and refining that radiocarbon dating has undergone. Furthermore, cellulose clocks are extraordinarily sensitive to environmental changes. The shroud has a documented thermal history. In 1532, it narrowly survived a fire in Chambéry, France, enduring temperatures high enough to melt the silver of its reliquary. Intense temperature spikes can artificially accelerate the breakdown of cellulose, making the fabric appear older structurally than it is chronologically. Combine that heat exposure with unrecorded variations in storage humidity over 7 centuries, and the baseline degradation rate becomes difficult to verify. Skeptics also point to the sample size. The thread analyzed in the 2022 X-ray study measured just 0.5 millimeters by 1 millimeter. Because this microsample was extracted from the exact same edge utilized in 1988, it raises the concern that it may not be representative of the entire 4-meter cloth. Because structural dating cannot retroactively account for environmental traumas, like the 1532 fire, many scientists argue it cannot override the established isotopic data. This leaves a divide. On the isotopic side, we have a high-precision dating method pointing to the Middle Ages, but one potentially compromised by chemical contamination. On the structural side, we have crystallographic metrics pointing to antiquity, but these are limited by their sensitivity to an unrecorded environmental history. Today, the physical reality of the artifact is strictly managed. It is kept inside a reliquary filled with an inert argon atmosphere, maintained at 19 degrees Celsius and 50% relative humidity. These conditions were chosen specifically to halt further cellulose breakdown. There is a scientific consensus on the only way forward. Resolving this requires a non-destructive, multi-point sampling protocol, testing dozens of locations across the entire surface of the cloth to establish true chemical homogeneity. Until the Vatican grants access for that level of analysis, the data remains in a stalemate. The Shroud of Turin remains a point of collision where forensic metrology, polymer chemistry, and historical provenance meet without resolution.